Hello, everyone. In this video, we will introduce polymorphism. In Java, polymorphism means that a variable of a supertype can refer to a subtype object. The three pillars of object-oriented programming are encapsulation, inheritance, and polymorphism. You have already learned the first two. This section introduces polymorphism. The inheritance relationship enables a subclass to inherit features from its superclass with additional new features. A subclass is a specialization of its superclass. Every instance of a subclass is also an instance of its superclass, but not vice versa. For example, every circle is a geometric object, but not every geometric object is a circle. Therefore, you can always pass an instance of a subclass to a parameter of its superclass. Consider this example here. So we have this is display object. This is the method. So what is this parameter here? So I'm going to have this is geometric object, and I'm going to give this is parameter here. The parameter is parameter. The type is geometric object. So I can invoke a get color. I can invoke a get date created. Now this, you can pass a circle object and you can pass a rectangle object. So the parameter here, object, the type is geometric object. You can pass any subtype object to invoke this method, display object. Next, let's look at this dynamic binding. So we're going to look at dynamic binding together with polymorphism. So we're going to see what is dynamic binding. Let's look at this example here. You create a geometric object. O, invoke O.toString. So what is the O? O is object. Object has this method toString. The object class has toString, and also geometric object has the toString. The exact signature is overridden. So when you invoke O.toString, which toString is invoked? That is dynamically determined at runtime. So this is called dynamic binding. So which toString is bounded to O, and that is depends on what actually O is. O is declared as object, but actually O refers to a geometric object. So that is why here it's going to invoke the toString defined in the geometric object class. And what you're going to see is in this diagram, so we have this, all these classes, C1, extends C2, extends C3, all the way extends Cn. Cn has to be this, is the root of all the classes that's object. So Cn is object. So you're going to see if this method here is in the defined in the class C1. If not, we go to C2, then all the way go down to the top until you find it. And that is dynamically binding in this process when your program is executed. So let's look at this example here with this method M. We have this M is the object. And we're going to pass graduate student, pass person, pass object to invoke X.toString. So for the graduate student does not have the toString defined. So we're going to its superclass student. So we're going to find the toString defined here in this student right here. So that is what you're going to see. It's you can display student for this method invocation. And the next one is students right here. So it is toString. This is going to display this. So now you can see this is display a student. All right, the next is the posen. And the posen right here is this toString is defined. So that's posen. So posen is here. And the last one is object. So the object, this is the memory address, the name of this object at this memory address. So what is dynamic binding? Dynamic binding is in this situation here. So you have this method to invoke. Exactly which method is invoked is dependent on this object. So this O, if this refers to geometric object, so now geometric objects toString is invoked. So if geometric objects does not have toString defined, it goes to look for the superclass, all the way to object. That is all for dynamic binding and the polymorphism. See you on the next video.